we really appreciate your inviting us today. Engineering the Future the MAD way. We've gone mad, so hopefully you will as well when we get done here. So it's great you did Agile 101. We kind of view this so maybe Agile 301. One of the things we always use as an analogy is that Agile for software is kind of like playing checkers, where Agile for hardware is kind of like playing chess because of the number of variables, the number of pieces on the board at any moment. So it's kind of a different game in a lot of ways. So that's what we're going to go through. I'm Dorian on the left. I used to be an electrical engineer, and you can't be an electrical engineer without getting involved in software. And went through the ranks, engineering management, moved over to product management and executive leadership and consulting. So I've been around the block, and I'm the founder of the MAD framework, and saw the need for Agile quite early. We'll talk about stage gate and the transition to Agile and why that's important, and also why we need to modify Agile for hardware. With me is one of our MAD partners, lead consultants, Vishal. I'll let him introduce himself.
Hey everyone, based out of Austin. Slightly different path. I kind of came in more through the software side of the world. Had started with Agile Journey 2006. I've done some PMO. I've run PMOs, change leadership, transitions to Agile, all that kind of good stuff. Um, and essentially had done some stuff around hardware for Agile organically, or Agile for hardware organically, Thermo Fisher and all. And then eventually I kind of ran into Dorian, and it all kind of makes sense. It's a very structured way of doing things. And I love looking at the top-down view in terms of the organizational flow state. So I kind of thinking right about that, and how can organizations get into hyper productive states and stay there. But I'm excited to be speaking with you all.
Great. So here's what we have planned. We have about 40 minutes of content, and we'd love to open it up to Q&A at the end. That's where we enjoy it the most, really, is getting your questions, specific challenges, etc. So I'll kick us off about 20 minutes, talk through our vision, the benefits, what's different? Why do we need to think about Agile for hardware differently than software? Vishal's going to walk us through the MAD framework a little bit, the key elements, why it works, some of the key concepts. We'll share 3 project case studies with you. Hopefully, you get to see it in action. And generally, it's nice having 2 of us because while one of us is talking, the other one can hop on chat. If you have questions in chat, feel free to do that, and Vishal will answer. I'm going to be clicking, so I probably won't answer when I'm not presenting, so I got to keep Vishal going with my clicks here, but I'll do my best to monitor it.
And
Um,
before you start, sorry, can we do that quick poll, please? I think
oh,
Mike has
sure,
it.
yeah. Is there any visual or just a verbal?
There we
Okay, I
go.
launched it, so hopefully it should
Oh,
be a pop-up.
great. I don't see it. I'm hoping others do. Oh, there it is. Got it. Great. Yeah, it's always good to know our audience a little bit. Some folks are already very experienced with Agile for Hardware, and it's obviously a very different discussion than folks that are new to it. Okay, great.
Well, so far, it looks like a really good mix.
Yeah, a good blend here. Great. 19. Looks like we've paused at 19, so minus us 3. Pretty good. Okay. So yeah, some folks just new to it, 1 or 2, and a couple experts. So that's going to be a good discussion. So we're going to go through at a pretty healthy clip, assuming you're kind of in the middle. So that's probably good. So really is quite distributed. So that should be a good discussion. And we'd love to hear the folks who have the experience in it to see how it relates, particularly to the MAD framework. All right, let's dive in a little bit to the problem and why we even think Agile might be a better way for hardware. And you probably all quite familiar with stage gate or waterfall processes. And I used to do these for years as an electrical engineer, moved into product management. I used to write lots of requirements documents, pass them over to engineering and, pray that a great product came out. And you know that the front end is the hardest part. We often call it the fuzzy front end. And there's a lot of assumptions that we make. And as hard as we try as product management to get the best definition, and we'll define things in P1, P2, P3. And we know it just doesn't work very well because we pass it over to R&D and then they do their best work on assumptions. You don't really take time to do experimentation because that's not the process. They don't do a lot of real collaboration with marketing even, and it becomes a contract almost on a piece of paper of you're going to get this product on this date and trying to live with all those assumptions you made up front. So we know it doesn't really work very well, doesn't drive innovation. Learning is always, very late in the process, and that causes all kinds of things like delays, cutting important features, and all kinds of uh, bad, um, um, bad results. So waterfall or stage gate, it really was never designed though as a way of working. It was designed as a governance framework. And at each gate you had a big checklist of items. You had a big dog and pony show with management, and is the project on track? And hopefully it was meant to be a go, no go. And the irony is, it's really not even very good at that because very few projects are actually killed. But that was really what the original design was the governance. Are we on the right track? Is it moving forward? And all the I's and T's dotted. So it doesn't do much for a way of working. Agile kind of moves the pendulum in the complete opposite direction, and it's really a way of working far more than a governance process. So you're all familiar with the Agile Manifesto, so we don't need to go into that in the details of Agile for software, but we know it works. Um, Teams see benefits, companies see real speed, they see higher quality, and there's a lot of statistics that show that. And they get it through time boxing, delivery in short cycles, better collaboration, focusing on incremental value and consistently prioritizing value and having flexibility. And one of the statistics I love is that software teams can go 500% faster with Agile. And how is that even possible? Because the statistic is based on launching the first product, where you can develop an MVP, which is a basic set of functionality, get in the market, test it, and keep building on it because, hey, it's software, it's flexible. And this works because you can do it. You've got a continuous flow of releases. There's really not a lot of cost to change. You're not happy with that feature, let's change it the next sprint. Let's reprioritize. Let's do something different. And we can do that in short cycles, plan, build, test almost daily. And even the team structure is has some pretty, I wouldn't say homogenous, because we know there's a lot of dedicated roles in software, but there's a lot of shared skills. And you can pull off different features and capabilities. And if I can't do it, then Betty can because we have some shared skills. And it really was designed more of a way of working than governance because software doesn't need as much governance as hardware. And that's because hardware is honestly just plain different because everything about it is different from the business model to how we select projects. The constraints on projects are much more rigid. We've got specific time, cost, specification constraints, and we have cross-discipline teams where we'll have electronics, mechanics, firmware, software, manufacturing, all kinds of different disciplines have to come together. And schedules are actually really important. And that's important for more than the fact that we just want to deliver a product. It's the fact that it's a constraint that forces the team to create trade-off decisions. Where software has priority decisions, hardware really has hard trade-off decisions, and that's a huge distinction between the two. And we have to make decisions in hardware, everything from which market are we targeting, which customers, which applications. And at the end of the day, you usually get one message for a particular product, why this product, their USP, why this product is more valuable than all the competitors. And once we make these difficult trade-off decisions, we have to live with them. It's got to be holistic. They're manufactured. We have to support it in the field and all kinds of things. And because every trade-off decision in hardware has a direct market impact in terms of price, in terms of market share, in terms of customer value, we have another dynamic is where executives like to come in and help drive decisions on hardware far more than software. Software teams can be somewhat more autonomous because hey, it's just features, we can correct it. You get lots of requests from executives, but it's more flexible. Hardware teams, they can change things literally in a second by an executive decision. So these are all things that we have to manage. In Agile tactics, when teams try to apply them directly to the hardware, they quickly realize they just don't work. And really, we shouldn't expect them to work because they weren't designed for hardware. It's almost like, can I take a dental drill and make it work in my woodworking? It's just a tool that wasn't designed for the problem that we have. So we know it's different, and software manages streams of incremental value and focusing on that. What's that next feature? And hardware is often managed as a product portfolio where we're making tough decisions on which products, which markets, and then we have to make those optimal trade-off decisions. So just everything about it is different. And ideally, we have one framework that can satisfy the whole spectrum. So one of our focuses is, making sure that any process that a company puts in place isn't just for software or hardware. It's for both because of course, not just the trend, but the necessity is integrated systems, and we need hardware and software to align at any point. And the value of Agile for software tactics goes down dramatically as you start removing hardware and software components. So we want something that works across that whole spectrum. We came across this video from one of our customers who shared it with us, and we'll share a little bit why they shared it with us. But I don't think Vishal or I could do a better job than Steve Jobs explaining what's the challenge of Agile for hardware or hardware development in general. He didn't call it Agile at this point, but what's the challenge of product development and what's the right approach to think about it. So we're going to share this about 3 minutes and then and see what you think about this video from Steve.
What's important to you in the development of a product?
One of the things that really hurt Apple was after I left, John Sculley got a very serious disease. And that disease, I've seen other people get it too. It's the disease of thinking that a really great idea is 90% of the work. And that if you just tell all these other people, here's this great idea, then of course they can go off and make it happen. And the problem with that is that there's just a tremendous amount of craftsmanship in between a great idea and a great product. And as you evolve that great idea, it changes and grows. It never comes out like it starts because you learn a lot more as you get into the subtleties of it. And you also find there's tremendous trade-offs that you have to make. I mean, there are just certain things you can't make electrons do. There are certain things you can't make plastic do or glass do. And as you get into, or factories do, or robots do. And as you get into all these things, designing a product is keeping 5,000 things in your brain, these concepts, and fitting them all together in kind of continuing to push to fit them together in new and different ways to get what you want. And every day you discover something new that is a new problem or a new opportunity to fit these things together a little differently. And it's that process that is the magic. And so we had a lot of great ideas when we started, but what I've always felt that a team of people doing something they really believe in is like when I was a young kid. There was a widowed man that lived up the street, and he was in his 80s. I think he might have paid me to mow his lawn or something. And one day he said, "Come on into my garage. I want to show you something." And he pulled out this dusty old rock tumbler. And it was a motor and a coffee can and a little, band between them. And he said, "Come on with me." We went out to the back and we got some rocks, some regular old ugly rocks. And we put them in the can with a little bit of liquid and a little bit of grit powder. And we closed the can up, and he turned this motor on. He said, "Come back tomorrow." And his can was making a racket as the stones went around. And I came back the next day, and we opened the can, and we took out these amazingly beautiful polished rocks. The same common stones that had gone in through rubbing against each other like this, creating a little bit of friction, creating a little bit of noise, had come out these beautiful polished rocks. And that's always been, in my mind, my metaphor for a team working really hard on something they're passionate about, is that it's through the team, through that group of incredibly talented people, bumping up against each other, having arguments, having fights sometimes, making some noise, and working together, they polish each other. And they polish the ideas, and what comes out are these really beautiful stones. Yeah.
So I hope everybody can relate to that. And that was from a PBS interview in 1995, even before Agile was much of a thing. And I love how he captures the problem. He talks about the disease and we see that all the time. And I saw it as product management. You see it in engineering, that you create even the best PRDs and you expect this idea, even if it's well captured, is going to magically turn into an amazing product. And we know it doesn't work that way. So Steve captures the problem and solution, amazingly, that takes that passionate team. It takes the ability to learn and adapt and weigh 5,000 things, these trade-offs, and having a process to do that. And excuse me. As you can tell, Steve was a visionary. He had a mindset way before Agile was even a thing. And we were really blown away when one of our customers called this to our attention, sent it to us and said, we wanted to share this with you because this is how we view the MAHD framework. It's helping us do this, helping us polish our ideas into great products. So we were blown away that he made that analogy, or that he made that. So what is modified Agile for hardware development? Well, it is based on Agile principles, but it's really about a market success framework designed to optimize a team's way of working while meeting the needs of physical solutions. And that's a lot of words for really saying the same thing Steve said, which is a process to transform great ideas into great products. And the key words here are underlined, is market success, because a lot of teams view Agile as a product development process. And we're going to use it to execute. We're going to do it in 2-week chunks, and we're going to write user stories, etc. But it's because of those trade-offs and how important it is and how each decision impacts market success, it really has to be a market success framework. And that's why we really need to bring in product management executives into the conversation and into the process and way of working. So, and that's one of the challenges teams have. So, bringing the elements together, and Vishal is going to walk us through some of the details, but we want to bring in the way of working that Agile has shown and proven. We don't want to lose that, to focus on value, how to collaborate in a consistent way, the transparency of projects, managing risk, priorities. We want to keep all of that, but we have to bring in some project governance. We've got schedules to hit. We got to communicate with everybody. We got external stakeholders. We need some sort of structure to make those difficult trade-off decisions. And so we need to bring that in. It's not directly stage gate, but some of the same ideas. And also we have other things we need to align with. There's often Six Sigma, lean processes, all the way through manufacturing. Some teams, of course, use design thinking. So we want to make sure that anything that we do works in parallel, in conjunction with the way the company operates in other areas that it's already found successful, including if companies are using SAFe, for example, Scaled Agile for Enterprise. So we want something that can align and work with all of that. Quick history, we've been doing this for quite a while. Before 2016, we started really trialing it, formulated, and it really, for me, the spark came working with a client who was trying to implement Agile. The software team was getting it quickly, and the hardware team was just struggling. And they were looking for all the traditional artifacts, PRDs, architecture, and we literally had to take a step back and say, okay, what would this look like? If we applied the principles to Agile and we made it work for the hardware teams, what would it look like? And that was kind of the spark of putting some of the elements together.
Can I ask a
It's
question,
evolved. Yeah, of course.
Dorian? So who is the main? So just for your last slide, there's a lot of
Yeah,
methods there that you're trying to, bring together and
yeah.
sort of make work for this. And I appreciate that that's even in if you're just trying to use safe, there's often a lot of things you're pushing up against. So who is like
Right.
I don't want to use gatekeeper, but who is like the main who are the main principals, the people who are sort of responsible for
Like owning the MAD process,
owning
owning
this,
the
like
way
who's
working.
going to put
Yeah,
yeah. Okay, I don't know if you're
yeah,
going to touch on that. Okay.
yeah. It's a great question, and it's actually a struggle for a couple of reasons. One, the sales process, as you can imagine, is who do you talk to in the organization, through to who owns it. And typically, the immediate traction comes from R&D because it is viewed first as a development process, and they get tremendous benefits from it. And then you bring in product management because they have to participate in a lot of ways. And once they learn about it, then product management and marketing see the value as well. And then it's those two groups. So
It's
ideally,
mostly
the
owned by
champion is somebody
R&D.
above that, but
Mhm.
it's those two groups.
So mostly owned by R&D, but championed by just very similar to software. It's like mostly owned
Yeah,
by the teams, but yet championed by folks higher up in the decision making.
yeah,
Cool.
yeah, exactly. I mean, they're the ones seeing the ultimate benefits, and so that's often key. Um, so we're going to talk today mostly about what we call the core MAD framework, and that's the based on project excellence and how do you initiate, execute a project for an Agile for hardware approach. We can go broader than that. The complete MAD framework really thinks about the whole product life cycle, because as you know, particularly in hardware, you've got a lot of shared resources. You don't have full team staffed often immediately. Part of that trade-off triad is always resources. So every project's going to run up against other projects and priorities. So we really need to think about even Agile, not just as a project or a product development, but as a whole product life cycle, all the way through portfolio management to clarify resource allocation and decisions, prioritization, all the way through sustaining engineering. So we won't talk about all of that, but all that's available on the website if you want to go deeper. But we're going to focus on the core. Um, just to give you an idea of some of the results, we see a lot of consistent results. We've never seen a team go backward yet. Usually every team's looking for speed. Management's often looking for speed. You can definitely get improved speed, and a lot of that comes from the front end. Where software, a lot of it comes from MVP, and hardware, a lot of it comes from what we're going to call the MAD on-ramp. How do you initiate a project? Higher customer value, and what teams immediately see is higher team satisfaction, because Steve mentioned that it takes some of that friction, but we want healthy friction, and healthy friction is what allows you to move forward. Just basic physics, but difficult friction will slow you down. So we need healthy friction, and it's exactly what we want to accomplish with an Agile for hardware approach. So that's the introduction. Hopefully all that made sense. I'm going to turn it over to Vishal, and he's going to walk us through a little bit about the specifics of what are we talking about here.
Hopefully y'all can hear me okay. Thanks, Dorian. So like he pointed out, today we're just going to focus on the project level, which is core MAD. We're not going to talk about the entire complete MAD, which kind of goes into more of the portfolio and organizational processes. So the good thing is that a MAD project can essentially start with just a small core team. You don't even need the entire team to be engaged, because typically in hardware, it's hard to dedicate a team, a cross-functional team especially. The good thing about MAD, the way it's structured, is that you can actually kick off a project in anywhere from 1 to 3 weeks using what we call as the on-ramp. And we're going to talk a little bit about that in the next few slides. And then thereafter, the team kind of uses iterative cycles in a rapid learning process. And we'll talk more about that soon. So the MAD is applicable to any size project, which allows it to scale up and down the organization. But it is based on Agile principles to reduce risk, align teams, drive fast decisions, because there's going to be lots of trade-off decisions to be made all the time using inspect and adapt. And so again, the concept of good enough is very important, especially as teams inspect and adapt to figure out what more they need to do. So the MAD USP is that the tactics were actually built and purpose-built to support the unique challenges of hardware. Holistic schedules, integrated solutions across multiple disciplines, constraints like, hey, you got to limit the product cost to a certain number, certifications, third-party dependencies, compliance. Lead times are generally long in certain areas, and typically there are shared resources. So lots of challenges to deal with. So it's important to kind of do this right. All right. So basically, sorry. So we're going to talk about 4 things or elements, as we call them. There's lots of nuances throughout MAD, but we're going to, for the purpose of this conversation, we'll look at 4 key areas. So the first is this empowered Agile team with cross-functional skills that is willing to engage in healthy friction, to harness their collective wisdom to create an optimal product. Now, this is obviously if you all are, since most of you have experience with Agile, this is sort of table stakes when it comes to Agile success or any kind of success, right? You gotta have a team that's willing to, let the best ideas win. The second is what we call as the MAD on-ramp. And as any hardware team will typically tell you, you do need some level of holistic and advanced planning when you're building hardware. Now, this doesn't mean that you got to figure everything out in a stage gate approach, but you got to at least be able to identify the key areas to focus on as a team, and then rapidly initiate the project with a directional plan. So the big rocks, as we call them, that's what we're going to focus on first when it comes to MAD. The third is how to think, execute, and learn iteratively while making the trade-off decisions as you inspect and adapt throughout. And then finally, how do you set up the backlog, the cross-functional backlog that's going to have to align across multiple cross-functional teams with lots of moving parts. Like Steve Jobs was pointing out, there's 5,000 things to keep in mind. And so how do you kind of manage some of that? How do you build the backlog over time to kind of ensure that you have covered all the different things? So again, these are just the big key elements. This is not everything when it comes to MAD tactics. But again, they're built in. The purpose for that slide was to point out that they're built in Agile principles. Now, while so I don't know how many of you all play Super Mario, but for the fans of Super Mario, there's this thing called Rocket Boost at the start of the race. So while software teams are able to adopt Scrum quite easily, you kind of start writing some user stories. They're generally small. You can start creating backlogs, you prioritize them, and you start delivering code. Hardware teams can't necessarily do that. So they struggle. They need a holistic view. They need to be able to incorporate architectural pieces, before they can start deliver hardware iteratively. So they need a way to quickly get aligned so that they're all moving in the same direction without having to do over planning. So that's where the MAD introduces the concept of an Agile vision brief and the MAD on-ramp. So the vision brief aligns the whole organization on the strategic intent of the project, from the target customer to the market positioning to the hard constraints for that particular project. The MAD user stories clarify what the customer is wanting to achieve and why. So we also call them as outcomes. What are the customer outcomes? The product attributes outline the skeleton of a solution. So that's essentially the framework for a technical solution. The focus matrix, which is also the third step in essentially the on-ramp, is a tactic that enables the team to gain a common understanding of the biggest areas of risk and innovation. So we refer to them as fondly as our big rocks. And then this sets up the directional path to success through a preliminary prototype strategy and what we call as our IPAC iteration plans. We'll discuss IPAC in a minute. And then as a final step of the on-ramp, the team gets ready to start iterating by creating an execution backlog for their initial 1 or 2 iterations. Next slide, please. All right, so one thing I did want to point out, you heard the word user stories. User stories in MAHD have a very different purpose. In Scrum, user stories essentially describe your incremental features that are being developed, generally small. During sprint planning, developer can pick one, estimate it, get it done, and get it tested. In hardware, we can't do this. For example, if a story says, as a forklift operator, I want to quickly pick up my cargo so I can save time moving inventory. Valuable, important outcome. But one individual or engineer couldn't possibly deliver this or complete it in a very short amount of time. So the nature of hardware is such that satisfying a user need or a user problem requires a range of technical attributes, specifications, and disciplines to be able to satisfy that. So user stories in MAHD are higher level, and they describe a customer problem or a customer need or what's valuable to a customer. So generally, you're not going to have as many of them. There's going to be far fewer of them than compared to a software project. So while the naming is the same, the concept or the semantics are different. One of the things we also kind of refer to them as customer outcomes from time to time. So it's easier to separate the difference. So this is the big thing, like, the on-ramp that we talked about. It's a huge difference compared to your traditional approaches. So typically when you work through your early stage gates of the front end, it takes months, lots of contention about, and it is a contract negotiation, right? I'm going to hold you accountable to the project plan you create. But I don't know enough. Oh, okay, then here's what you need to know. And then there's a lot of assumptions baked in. So rather than collaborating, there's a lot of time spent on paperwork, back and forth, and so on and so forth. The MAHD approach, on the flip side, is about setting up the problem to solve, which is with the vision brief, as we talked about, with some of the user stories we talk about, and then collaborating as a team to solve the problem while you address the big rocks first, with the highest value, highest risk. So in the same time, typically, that a traditional team would have worked through their PRD specifications, architectural documents, and built a Gantt chart, MAHD teams typically would have worked through major areas of risk and innovation with some early prototypes. They would even have gotten feedback from customers and would have started making early trade-offs. So the result is you have much earlier risk reduction with a far more predictable schedule, with better clarity about the resource needs and a better understanding of what's driving the customer value. So you're now more focused on what's valuable to the end user rather than just building something.
So the IPAC iterations, was the IPAC stand for again?
Yep, that's your
Good
perfect lead in.
question.
So the second big element.
I'm not a plant. I'm not a plant.
No, that was a good setup. But that was the second piece of the second big element, which is the IPAC iteration. So the second major area is how do you execute iteratively in hardware? So in software, an iteration is basically a complete and releasable features, but hardware, obviously, you can't do that every 2 weeks and such. So that's why the MAHD has the concept of IPAC iterations. For every iteration, which is basically, if you look at the outer circle, the red in the picture, the team is working through the IPAC acronym, which it stands for the P. We'll start with the P because that's typically where the team will start, is what's the right level of prototype for what we need to learn. So the key thing I want to call out is that it's about rapid learning, and it's a learning process. So the mindset and the framework is built around how do you learn? How do you learn the unknowns? How do you get through the big rocks? So first is, what is the right level of prototype that we need? The I stands for, hey, what do we need to integrate across every function? A stands for how and who do we need to align with? Whether there could be functions outside the team, executives, third-party vendors, partners, whoever that is, right? So, but the team has a focus every iteration to say, hey, who do we need to align with? What are the dependencies? What are the alignment pieces? And then finally, C is, hey, what do we need to validate using customer feedback? So at the end of this increment or iteration, what do we want to learn, and how are we going to validate that we were on the right track? So the system level iteration goal drives the focus of each iteration, incrementally building and validating the solution via prototyping. And then the customer feedback is used to make the optimal trade-off decisions throughout. So every increment, that's what's going on. We use the longer iterations, the IPAC, the outer circle, to identify the big and small learning milestones and alignment that needs to happen, dependencies and alignment that needs to happen along the way. The shorter iterations, which is the inner circles, are the 2-week sprints that allow each subsystem or discipline to work within their teams to manage their tasks and work towards the larger iteration goals. So again, the larger goals will drive the goals within individual swim lanes. They execute those as sprints, and then everything comes back together in terms of essentially, hopefully, demonstrable outcomes at the end of every iteration. So we'll talk a little bit more about how that kind of works as well. So a couple other key concepts I wanted to make sure we talk about. Next slide, please. Yeah. So a key consideration for iteratively evolving the solution is, how do we define a prototype? So in MAHD, we define prototype as a demonstrable output for the purpose of learning. Now, this can be anything from a diagram on a piece of paper to a 3D model, or even something that's 3D printed. It could be a partial component. It could be a partially working solution. It doesn't have to be the entire end-to-end solution every time. As the project evolves, the prototypes will gain functionality and fidelity as the learning requirements become more targeted. So everything evolves over time, including the prototype and the fidelity of the prototype. So related concept to prototyping is the vertical slice. And a lot of people have heard this in software, not a new term, but typically the idea is, you start the iteration saying, hey, what do we need to learn next? And this is often one of the outcomes of the on-ramp. As you come out of the on-ramp, you have these big rocks, and you're like, hey, what do we need to learn? And obviously it continues to evolve as you learn and as the project progresses. But a vertical slice is a portion of the system that comes together to learn something, to validate a technology, validate a functionality, and get it in front of customers or users, or it could be other stakeholders. But the idea is to constantly, build little pieces that can come together more in an integrated fashion. So if you needed to validate, for example, whether you have the right interface functionality, you might build a vertical slice of a partially working PCB, some early firmware and software, but no chassis. And then each of the disciplines works through their portion within the sprints while collaborating across themselves to hit the iteration goal, which might be to bring all of these things together to say, hey, is this workable? Are we in the right direction? So MAHD Agile, the way we envision this is, it's not a serial development of features that just incrementally layer on, but essentially, how do various features combine and integrate to satisfy the user problem? And that's the key focus, and that's what we coach and train the teams to think about, is the value aspect, right? As you mentioned earlier. So this particular slide is going to start bringing all of it together. So it's a nice visual that will help explain how MAHD comes together. So how can you start with a skeleton solution, no detailed requirements? And so typically, after the on-ramp, the team begins investigations on what we refer to as the big rocks. So the on-ramp, they would have identified what were some of the key areas of innovation potentially or unknowns. And then they would start working through that. So they get into these rapid divergence convergence cycles to start mitigating the areas of risk and the biggest areas of innovation. As the big questions get answered, more becomes known. They start locking things down where it makes sense, or they continue to do more divergence convergence cycles until they get to a point where they're able to validate the solution. It makes sense. It's an optimal solution. So again, there's the good enough that I mentioned earlier, right? It's very important for the team to be constantly asking, is this a good enough solution? And then basing the trade-offs and things like that along the way. So later in the project, you might have a situation where maybe there's a very important critical area there where you could squeeze in more performance, for example, and the team might decide to leave that open as what we call strategic flexibility, and then lock down everything else while they hit design freeze. So again, in hardware, you have to have those milestones in terms of design freeze and so on and so forth. But again, we have flexibility built into the framework to allow teams to make the right calls. And as the teams work through the big unknowns, what's going to be left is going to be much more predictable. So in this particular example or diagram, right, as the investigations become less and less, the team actually knows most of it. You know, for most people that understand estimation, it's effort, complexity, and unknowns. And typically, most teams get stuck with the unknowns, and that's where they spin. And so what we're basically saying is, hey, we need to address some of those unknowns as early as possible, because then you can actually become more predictable. Once they know what they have to do, teams are really good at it. So again, the team will address the high risk, high value items first, demonstrating progress throughout, validating their hypothesis in some of these areas, and adjusting the plan based to reflect their learnings and trade-offs. So the next area of modification we talked about was the backlog. For software, backlogs often essentially a prioritized list of features in the form of user stories and technical tasks. So the format we can still use is similar. A product owner is responsible for keeping the list prioritized, setting the acceptance criteria, and so on and so forth. You all know exactly how that works. As you can imagine, you can't really do that for hardware. It's pretty much impossible for one product owner to own the backlog across disciplines, right? What electrical, mechanical, software, firmware, a single individual is going to have a very hard time trying to create acceptance criteria and stories for everybody. So in MAHD, system level epics capture the top level IPAC iteration goals. These are then broken down by swim lanes for each subsystem or discipline, and then prioritized within that swim lane. Since it would be impossible to prioritize mechanical tasks against electrical firmware and such. So in MAHD, every swim lane is typically owned by a technical lead or a discipline area leader, and then they kind of work with their team to do the task estimation, sprint planning for their swim lane, so that again, the whole purpose is to have that integrated IPAC goal that they're trying to hit. Now, just a quick small call out. Obviously, there will be scenarios where individual swim lanes might also have some unknowns. So obviously, that's what they would also kind of prioritize. But typically, the idea is that first you satisfy the big picture and how you need to contribute to that, and then you kind of take on whatever else you need to do as well. So net, if you can, yeah. So net, the business value of the MAHD approach versus a traditional approach, which uses Gantt charts and such, comes down to the risk profile. Stage gate starts out typically okay, often with reasonable confidence built around the Gantt chart. But as the project progresses, reality starts setting in. Assumptions start failing, which then lead to project delays, changing requirements, and risk just continues to accumulate. Typically, the risk gets pushed out until a time when, hey, you know what, we have the stage gate coming up or something, and then hard trade-off decisions have to be made. With the MAHD approach, The focus is on identifying the risk and the unknowns and the opportunities for innovation early, tackle them quickly, learn, validate, reduce the risk upfront, so that's built into every IPAC iteration. And the best part, like I mentioned, is that the predictability actually goes up in a MAD project compared to a traditional project as you get through more things. So that's my section here. I'm going to hand it back to Dorian to take us into some use cases. I'm sure there was some stuff on the chat, but Dorian was also clicking through, so I'm not sure how much he was able to answer.
There's one question about, do you have cross-functional teams or cross-functional team of teams? I think on the
It depends
last.
on the size and scale of the project. So the swim lane can essentially be either electrical, mechanical, and so on and so forth, or depending on the size of the project, you could literally have subsystems there, right? So it could be an entire subsystem that has hardware, software, everything, and another subsystem that also has other cross-functional groups. So that depends on the scale, which is why MAD was built to satisfy at any level. Small teams can potentially have just the swim lanes by discipline. Larger ones will have by subsystems.
And it's one of their goals of the on-ramp is to work through that. So what's the best way to structure this team? And often you're starting with a subset of the team, so you kind of set that up and you set up the backlog so that it reflects the needs of the project. So across the board, we want a framework that is literally flexible to the needs of the industry, to the type of project. That's why IPAC iterations are flexible duration. Often there's very short cycle between longer cycles for learning before you to inform the longer IPAC iteration afterwards. So we want the needs of the project to dictate a lot of this, and that's why it's got to be a lot of flexibility built in. So let's walk through a couple of case studies. Maybe this will highlight some of the things that Vishal was talking about and where some of the benefits come from. And I'll go through these quickly because we do want to leave at least some time for Q&A. The first one is an industrial process control company, and these are meters, and they were working on towards more intelligent meters, and they had a lot of questions, as you can imagine. What does that mean? What are the right attributes of the solution? And they had a very sophisticated product manager. They wrote 400 requirements and did a great job with that. But it was taking forever to work through what these were with the R&D team because they were questioning everything and asking about why is this important? How many more will you sell if we do that? It just was taking forever. And we see this all the times in organizations that both sides want to get it right. Our product management doesn't want to leave anything on the table they think is important. R&D wants to really understand everything so they can estimate it and break it down as much as they can based on all of the assumptions. And it just takes a long time. So moving to the MAD framework, they generally said, let's just focus on breaking these requirements apart. And so rather than starting with requirements, we break it into its two fundamental components. We start with the customer outcomes in terms of user stories. So the team wrote user stories, of course, starting with that strategic intent. What are we trying to accomplish with this solution? What's the positioning in the market? What are we really trying to do to differentiate? Get clarity on that, and then really identify what are the customer outcomes we're trying to satisfy and what priority and who the customer is. And then the table turns and R&D responds to that with product attributes and says, okay, based on that, we think this is the type of attributes, these are the subsystems, these are the major components it will have, and these are the areas that we have big questions about. And then we pull it together through matrix thinking to identify which of those attributes are most aligned with the most important strategic factors and these customer outcomes. And if there's unknowns there, those become those big rocks and we start working on it. So rather than getting agreement and alignment on the specific requirements, the team got alignment on what's the path to learning what those requirements are. So it's really just a completely different mind shift. And through working through rapid prototypes and feedback loops with customers, They were able to reduce the front end by 80%, what would typically take months down to a matter of days. They were able to quickly line the team, work through those learning cycles, and get even time to market was 40% faster than they typically see. So um, another example is a satellite communication encryption solution, similar. They had very long front end, but for a slightly different reason, where they wanted very sophisticated solutions. They were creating a new encryption protocol in this case, and the R&D team always wanted to develop integrated, elegant solutions. And it would just take a long time to work through what that meant, what the schedule would be, how to approach it. And so what they did, taking a more agile approach with the MAHD framework, was understand the constraints a little deeper. Like, okay, can we get this to market faster? Because they were often always behind the market leader in this on new protocols. And they started with a simple question in their on-ramp is how might we develop a prototype that we can trial with customers in 9 months? And by just setting that problem, and if you ever ask ChatGPT, what's the number one thing that engineers love to do? And it will tell you it's solving problems. And I used to be an engineer, and that's how I would respond. That's why we went into the business of engineering. And so what we're doing is setting up that problem for the team to solve, and they were able to do that. They rethought the architecture. They left a lot of the functionality on their main board. They created a daughter board with this new encryption. They built an interface to do that. They developed a prototype, got it into the hands of customers in that 9 months, and customers were so satisfied with it, they just productized it, and it became the actual first product in 15 months. So they're able to get a solution in the market 33% faster than typical first to market with this encryption and decryption capability. And then it also gave them a path to what the R&D team really wanted, which was that integrated solution. So they had to adapt to how do we think differently and get a product out there. One of the key concepts in software you're all familiar with is MVP, minimum viable product. That's what gives you a lot of that speed, especially up front. For hardware, a lot of teams hear that term and they focus so much on that minimum. And it scares management, it scares leaders that we can't put something out there minimum because we can't update it. We can't upgrade it in the field. And that's usually the case. So we like to think in terms of OVP, optimal viable product, because you have to think about the longevity in the marketplace. You have to think about the limitations of upgrading in addition to how to get something out quickly. So it's just one of those things where teams have to think a little differently from software and hardware. But similar concept can apply. The last example is in robotics, and this is a domestic robot solution company developing a new robot for office cleaning, which I'm sure we could all use. And they were actually quite happy with their development cycles, about 18 months, because they knew that the more products they had in the market, the more they'd have to support them, the more they'd have to train, the more product parts they'd have to inventory. So a lot of times, just because you can deliver a lot of products fast, there's a lot of negativity to that. There's a lot of cost associated with that. And so they were fine with that. But the problem was they wanted to increase their margin. And their margins were pretty low because they develop a lot of features. They'd add a lot of features that customers didn't really value or want. And that was the result that product management would write in a lot of features that they knew R&D would cut because they were always trying to hit these schedules. And so it was always this game a little bit. And so R&D would deliver a lot of features, but they were never the right features. And so they implemented a MAHD framework to figure out how to optimize that relationship as well as how to optimize that with customers. So strategic intent, back to what are we trying to accomplish with the solution? How do you build in customer feedback loops? So that was the key, was how to get those early prototypes, even paper, digital simulations in front of customers to learn which of these features we're considering are valuable. Was able to keep refining that, remove things that didn't make sense, and get their margins up. And margins can come from two places. You can increase your price, or you can lower your costs. In this case, they're able to do both because with a better launch, a more predictable launch, they were able to communicate the value better. They would have a harder launch, higher impact launch, and a lot less price reduction, a lot less offerings they had to give to get sales at the price they wanted to get. And then, of course, the overall cost was down because they were able to reduce features. So it does work. It's just a tool. We're going to end this with another Steve Jobs story. And I was very close to this industry at the time. And if you don't know, Apple was pretty much almost bankrupt before Steve Jobs came back in, I forget what this was, 2000, about 2000. Um, and he worked hard to get this product into the market, the iPod, and this is really what saved Apple. And as we mentioned earlier, Steve had an agile mindset before agile was a thing, and what they used to do is they created prototypes very early in the development of foam mock-ups, and they'd put lead weights in it, and they'd have people carry it around, and they'd identify what the optimal form factor was. And that gave the problem for R&D to solve. It says, here's your real estate, here's your volume, here's the dimensions. Create an amazing MP3 player with hard drive and fits 1,000 songs in your pocket, and here's your constraints. And the team did it. And that's why Agile has to be really a market success factor. One of the key competitors in the market at the time was Rio. If you're familiar with that, they're really the pioneers of MP3 players. They did not really follow agile practices other than some of the execution, doing things in short cycles, and they didn't really think about the overall market success and how to approach it. Of course, you know the results. iPod took over the market in about a year, over 70–80% market share. Rio was out of the market in 2 years. So we know Agile for hardware works. We know the principles work. It's just really adapting it to the needs of the team, to the needs of the project. So just to summarize, if you want to learn more, feel free to reach out to us, Vishal or Dorian. We're easy to find, mahdframework.com. Happy to share learning options. The easiest place to get started, learn more, just go to mahdframework.com. I saw, let's see, Maggie, you said agileforhardware.org or mahdframework.org. They kind of all go to the same place. So, but mahdframework.com is the official website. Download the resources, white papers, and you can get started that way. With that, I know we went through a lot of information in a very short amount of time, but we'd love to open it up to questions. If anything came to mind, and we're happy
We
to
did
stay
have
with you.
a quick poll as well. Maybe if we
Oh,
have a couple minutes or so, maybe we do that second poll, please.
yeah, that'd be great.
What do you think, Maggie?
Yes, let me pull it up here. Pull and go back. Launch. So it should pop up on everyone's screen here. And MAHD closing poll. I want you guys to talk at all my things now because I want to call everything MAHD. Like the MAHD closing poll. I got this MAHD event coming up. Everything's just
Yeah.
Yeah, we don't leverage that enough, actually. We get some interesting comments from people going, "Oh yeah, we love that mad thing you guys do."
I jumped on that right away when I was promoting
Yeah.
this one.
Well, you see my background, whether I've gone mad or we've gone mad.
Yeah, I like it. Oh,
Yeah.
I'm sorry. Let me fix that. I got a typo in there. Yeah, so hopefully everybody's seeing a.
Yeah, very interesting. And we would love to hear if you're open to it. Is the folks that are ones and twos, we'd love to hear from you. What's the concern, or either you don't see anything different, which is possible. You don't see the value. You don't think teams can do it. So what created a one or two in your mind? Anybody share that?
And the
It's
person
okay
who has
to.
no friends, feel free to reach out to me. I can't do that one.
Yeah. Well, and we often get questions like, okay, how's that different than, for example, scaled Agile for enterprise safe? And there's actually, you can see there are some similarities that we work on two levels of iterations. Safe with program increments, we have IPAC iterations, but that's about where the similarities end in a lot of ways. When we look at teams who learn safe, um, they're still kind of rooted in software, thinking that okay, let's identify a range of features that we're gonna develop in this increment, and then we break that down to user stories. It can work. We've seen it work, but usually teams really struggle and have to modify it even within that framework. Um, so there is some similarities, and we get that question a lot. I'll just ask it of ourselves here.
There's a couple in the chat here. You guys can
Yeah.
see.
Yeah, and roles is always a good question. I'm looking earlier. One of the key roles. That's why earlier I mentioned we kind of equate. I don't know, use an analogy or metaphor of Agile for software is kind of like checkers. Agile for hardware is like chess because of the kind of increased complexity. And part of that's because of the distribution of responsibilities required. That we require the technical leaders really to step up and think agile, help identify that next prototype. We really require product management to stay very involved because the learning is critical. Customer feedback loops are critical. Um, and then the third one is the agile project leader. We don't really use the term Scrum Master because we have to have somebody that has a bit of a blend of traditional and agile. Um, and that's why we call them an agile project leader. So they have to be a bit of both. But their role is critical. It's not just following the process as much as it is making sure the key concepts are embedded. What do we need to learn next, team? And we have a concept of look forward, plan back, where you're looking for that next major learning event and somebody's guiding, facilitating that. And then you have to plan backwards sometimes, a couple of iterations to get there. So you have major learning events and minor learning events, and somebody's got to orchestrate that. And that's why we really look to the Agile project leader to do that, but with deep collaboration from those other two roles. So in an Agile for software environment, if I have a great product owner, they can make it work. If in a Agile for hardware, I really need those three roles to work well together, and that's a bit of a difference. So we do have the role of a product owner also in that framework, but it's a very different role than it is in software. It's somebody internally looking that's kind of is the person that is the direct liaison with product management, but they typically can't make the tough trade-off decisions. They don't have the authority, they don't have the market awareness, but they're the internal representation of that, and they can guide the team on the intention of the project, the intention of the trade-offs, and help guide the trade-off decision. So these roles are going to be a little bit different. A lot of the titles may overlap a little bit, but how you think about them and how the responsibilities are going to be modified as well sometimes for hardware needs.
Cool. That was the the roles.
There's one other question I see. How do you deal with long lead
Yep.
times and dealing with non-agile suppliers? So I think in the very beginning, someone called out, hey, it's kind of hard to put so many different things along with MAD. So we have, safe and lean thinking and so on and so forth, which is exactly why, there's typically in hardware, so many cross-functional groups and areas, it's very common to hit situations where, hey, software does Scrum and Agile, and hardware can't do that 2 week thing. So how do we integrate? So there's actually the way IPAC iterations are very useful in that context to be able to bring everybody together, right? So you can align with third-party vendors. You can actually, any dependencies. So a lot of times with hardware, you have these SMEs that are not always available, that are not dedicated to the project. So again, same thing, right? Alignment, the IPAC alignment piece actually allows it. That's exactly why it's there, to bring everybody on the same page.
Yeah, and also teams struggle also, or companies can struggle when their customers are not agile. Especially contract. If you're a contract, if you have, so contracts to the government or other companies that aren't agile and they're looking for these detailed requirements to an RFP or something, it can work as you if you explain your approach and how you're going to get better results. We have seen customers really embrace agile methods, but that is it's not always easy. But having an approach that can bring them into it is critical if you want to have that discussion with customers. For suppliers, it's really the same thing in some cases. But one of the nice things about Agile in general is because it's more transparent, you can get more metrics from it. You start seeing, oh, this supplier is constantly our bottleneck. They're constantly holding us back. And then it allows you to either switch suppliers, which we know is not always possible, or to have better conversations on how you're approaching your development and how they might change for your needs if they're a good supplier. So it does have enable you to have better conversations with suppliers sometimes.
So there's a couple more questions online as well. Do you hold the team of team stand up? What new events did you add? So again, this the framework does suggest or propose, hey, if you have a team of teams and so on and so forth, you do need certain amount of coordination. But at the same time, it depends on the dynamics and the nature of the coordination and what kind, like if one group is does waterfall and another group is adopting MAD, how would they align, right? What kind of meetings make sense? So there is a certain amount of flexibility and customization, so to speak, because at the end of the day, no two organizations are the same. No, none of the alignment needs are the same. So it does, typically when we do the training and coaching and all this on, those are some of the things we do work with the teams to help organizations set that up. Because you have a project with 200 people kicking off, it's you gotta figure some of these things out, but none of this is obviously rocket science in that sense. So it's the logistics, right? So it's like, what tool are you going to use, what meetings and when, and who's going to be the owner for certain things, and the RACI charts or whatever. So that's
Yeah, the
typically.
core meeting. I'm sorry, Vishal.
Yeah, go
The
ahead.
the fundamental meeting that makes all this work is for teams is really the IPAC iteration planning and iteration reviews. The sprint, we often say the iteration is king in the MAD framework. The sprints are king in the software framework or Scrum. Sprints are more are lighter in MAD. The teams don't spend all the times grooming per se, debating pre-work, post-work. Acceptance criteria is more at the iteration level. Important tasks and things, we can do acceptance criteria at the task level at sprints, but that's not typical. And generally recommend peer level acceptance criteria at sprints and external validation for IPAC iterations. So there's a little bit of difference. The meetings are a little different, and the time of which ones are most important is going to be a little different. I love the question about how does MAD deal with stage gate? And we'll add dependencies. Stage gate is an interesting one. What we found is that one, they're very lineable. I mean, you think about it just logistically, you have a gate coming up. I could easily create IPAC milestones or goals to hit that gate. But we want to take a deeper, more flexible look at it. And what teams often do, and we ask them to do as well, is take a look at your gates, the purpose of it, the artifacts that are required, the management expectations. And generally what we see is about a third, a third, a third, where a third of the requirements of a gate weren't even necessary. We don't need them, not important. They were there because of, traditional waterfall. A third of them, the team is naturally doing. That is part of the MAD framework, just naturally because everything is evolving in parallel. They're hitting the gate milestone at any given moment. They're ready for a gate review. And the third, they have to do some minor modifications based on where they are in the project. And that third is typically things like business forecasts, getting certain approvals from people that may be outside the team, some things that the team's really ready for, but they have a couple of actions they need. And one of the key message to management in an agile environment, that the team is always ready for an executive review. And that's a very different message than waterfall, where the team is pretty much never ready for an executive review until there's a stage gate or a gate in the process. And then the teams scramble. We'll see teams work for sometimes 3 or 4 weeks with hundreds of slides and meetings and pre-meetings to get ready for a gate. And that's just wasted energy because the gate itself becomes more of the product than the product they're actually working on for the market. And so that's a huge cost savings, a huge waste mitigation removal is you can keep gates, no problem, but how you think about them and how you prepare for them should be rethought in the actually an
And you know
agile
what's
approach.
interesting is as we've kind of worked with a lot of different organizations and stakeholders and managers on this thing, what's interesting is if you basically ask them, they're like, yeah, I mean, I do need some governance and some visibility and all, but I will take joining a IPAC iteration review meeting every 6 weeks over these stage gates because I actually get to see real stuff. I get to see what progress the team has made, where they are, what's challenges they are, and I get to help them. They care more about that. Now, because Waterfall didn't offer any of that, then the stage gates kind of became prominent to say, hey, how else do I do the governance aspect of it? So,
Or worse, when executive or a stakeholder is not involved, well, that's where you got the flybys. They'll come down the lab or they'll come into a meeting and say, "Hey, I need you guys to think about this." And then all of a sudden the team shifts because that's what the executive said. That's what we got to focus on. Those are the kind of things that we need to, rethink, and that's why the market success process thinking is so important versus development thinking, that we're addressing executive concerns from the beginning because of the whole point about risk and trade-offs, because that's their concern. And if we're addressing them, then they don't have to do the flybys. They don't have to come in and, I won't use the derogatory terms, but to redirect the team at any moment because the team is already thinking about a lot of the same things they
so
are.
there are some really two good questions that popped up, and I don't know if we have the time, Maggie, but
Yeah,
I would
go
love
for
to
it. Go
answer
for
those.
it. This
Okay,
is yeah.
so Himanshu says, in your experience with MAD, have you discovered any efficiency that could be brought to Agile for software? Honestly, Dorian and I have had so many conversations about this to say, hey, we could literally apply MAD to software and work awesome as well, because some of the same it's built on agile principles. In fact, the on-ramp, for example, right? One of the challenges that you have with software, typically you don't have an on-ramp. It's like, hey, I got a bunch of prioritized stories and go, and then every 2 weeks show me what you got, which works, but what the on-ramp does is kind of allows the whole team to organize a little bit and think about, hey, where's the big areas of risk? Where should we spend our time? Where are the unknowns? Where's our opportunity for innovation? You don't do that in software typically. It becomes, as I do the user story, if there's an opportunity, I might do something. So it's not risk driven, it's only value driven. Whereas what MAD does is it kind of combines value with risk and opportunity. So one simple example of where MAD can be applied to software would add a lot of value. We also talked about the stage gates and stuff. A lot of organizations still have stage gates, even though they might have Agile for software. So you could still kind of do some of that, incorporate some of
I'm
that.
thinking big banks and highly regulated.
Yeah, compliance and so on and so forth. I don't know, Dorian, if you want to add anything to that question, and then there's another one about feedback
Yeah.
loops.
I love the next one as well. But yeah, we actually just had a customer who's using MAD for about 2 years, and they send us a note say, you know what, we just tried MAD with a new software platform we're launching, and we were surprised how valuable the focus matrix was. So we do see software teams see value in it. It's just from us differentiating it. Agile Agile's become kind of a, the people kind of forget the principles and it's kind of become the tactics itself. We hate to use the word dogma, but it's become, well, we use user stories, therefore we're agile. We do 2 week sprints, therefore we're agile. And you all know that's not the case, but it's so prevalent that if and we debate even using the word agile because it's so emblazoned in people's brains on what it is and what it isn't. But really often we call it structured common sense because it's the kind of stuff you just naturally do anyway if you had to start a process from scratch. Oh, sorry. I love the second one is the customer feedback loops. This is something dear to me as a product manager, ex-product manager, steeped in market research, because this is a challenge. We know it's a challenge for software teams, and it's definitely a challenge for hardware teams, is what's the best way to get customer feedback? And it doesn't, in Agile for hardware, it certainly doesn't mean, every sprint, even every iteration, we're going to bring in 20 customers and we're going to get feedback, or we're going to deliver them this working prototype and we're going to get feedback. The teams have to take a very strategic approach to it. We generally recommend setting up a customer panel or a couple panels, depending on their market, the homogeneity of it, what they need to do. But they need something to get the rapid feedback. And even a very small number of customers that go out to every fourth IPAC iteration is much better than typical. So as part of the on-ramp, they identify what's the right set of customers, usually in parallel with the prototype strategy, but sometimes different, is what's the learning milestones with customers, what are the techniques we're going to use, how are we going to get some help doing that, and that is absolutely a muscle that the teams have to build if they really want to be agile. Typically, that comes a little later. They kind of dabble in it at first, and that's okay because it is difficult and it takes a while to learn. But over time, you get more comfortable doing it, and then you learn where to bring in customers. And it starts, what do we need to learn? And learning comes in two sides, technical feasibility often, or commercial feasibility. And if we need to bring in customers, then they have to have the mechanism to do that. And all that has to be built in, take some time.
All right. And then did we focus on the feedback loop?
Well, that was, I was trying to address the feedback loop. I don't know if I answered that or
Sorry, I
not.
got busy on the chat, so I kind of might have not paid attention.
Yeah, yeah, that was my answer to the feedback loop. But the short answer is when you need it and how you need it, and it takes a while to build. Um, I'm looking there. Well, yes. If there's any other questions, we're still here, but sounds like we're getting close to the end of them.